Okay, so I hope you enjoyed your coffee. Now we are here with Christophe Pettus here. And we'll see how to embed Python into PostgreSQL. Thank you, Christophe.
Hello. So we're going to talk about Postgres, Python, and Squid. This is not the reverse proxy cache. This is the cephalopod we're talking about here. See? Squid. As I mentioned, I'm American, which means I speak very loud and very quickly. So please wave if I start becoming completely incomprehensible. So let's talk about Squid. So what is a squid? I mean, conceptually, what is a squid? So for the purposes of this talk, a squid has 3 attributes. It has a length in centimeters, a number of tentacles, and a weight in kilograms. Those are the defining characteristics of a squid. And of course, we're using Postgres because, I work for a company called PostgreSQL Experts, so duh. And we're using Python because, well, I'm going to talk about Ruby here. And we're using PsychoPG2 because there's really no other intelligent way right now to talk to Postgres from Python. So we all do something like this. We create a squid object with, it's an initializer, and, we set this, and then we return a string, and, there's probably a repr and, a bunch of other stuff here that we're not showing. And then we instantiate a squid. And then in Postgres, we do something like this. The squid has a key. Let's do a big serial primary key because, we're all used to Django, and that's the way you do it. And a length and all of this stuff. These probably should be decimals instead of floats unless we want really big and really small squids, but whatever. And, we want to make sure that we have, sensible squids, not alien exotic squids here. OK, that's good. And then we do an insert a squid in to the table. OK, and, commit it. And then we we get the squid back out. And then we instantiate we instantiate a new object out of the row we got. See, squids in Postgres. And we're done. OK, that was a short presentation. But then someone comes along and says, now we want 2 different tables, and they both have to have squid in them. And I said, oh, why didn't you tell me that before we did the first push? That's OK. We just replicate the schema. And actually, Postgres has this neat little feature where you can you could create Atlantic squid and Pacific squid and just say, I want one just like the one. I'll have what he's having. And by including all, you pick up the constraint also. So that's kind of neat. And then we write something like this. And then now, at this point, we should be thinking, wait a second. Having to do these string concatenation to build the table name, and that's always a sign that maybe you're going down the wrong path. You do it sometimes, if you're writing schema manipulation functions, that kind of thing. But since, sensibly enough, we can't do string substitution in there to do. We can't pass it in as a parameter to the execute call. We have to actually munge the string. And then in thinking, at this point we're thinking, wait, doesn't PostgreSQL have types? It says so right on the front page of the site. And maybe we can use the custom type facility. But then you think, OK, but this is things like PostGIS define types. And then you probably have to write C and PLPGSQL and probably scheme in Erlang or something to get this stuff to work. And you install a VM. It's going to be horrible. And then it says, well, that's great, but we want operators, and we want indexing, we want all that good stuff that comes with real types. And OK, you just don't do this. Python people, I'm sorry, you're just not allowed to do any of this stuff. But you would be wrong. I want to get the slide from one of the original Star Trek where Kirk spins around and says, you're wrong. I just think it'd be great here. It's actually really easy to create custom types in Postgres. And you can write custom Postgres types in your application without too much nasty code. A little bit of nasty code, but not too much nasty code. And you can write functions that run inside of Postgres in Python. You actually have 2 different ways of doing it. So Postgres has a really extensible type system. The reason we have things like PostGIS is because it's able to extend the typing system. This is the reason that Postgres gets PostGIS and other databases kind of don't. You can create your own types, and you can create. There are kind of 2 flavors. There are high-level aggregate types, which are structures of existing types that are already defined in Postgres, or you can define low-language C-level types that have their own bit patterns that are completely isolated from the rest of Postgres. We're not going to talk about those today. Now, something that's kind of interesting about Postgres is anytime you declare a table, you're really declaring a type. You're declaring a row type that says, I'm declaring a new type that has these fields in it. And oh, by the way, I'd like a table made out of that type too, please. You generally don't need to know this. It's hidden under the covers. But if you've ever written, how many people have any experience with PLPGSQL? Not bad. OK. Yeah, and you've passed around like record types and row type percent in that delightful syntax that everyone loves, row type percent sign type name. That's what you're doing. You say, I want one just like that one, which is pretty neat. But you can declare a type without having to create a table of it, like this. Bink. We say we want a squid, and it's going to have and it looks just like a table declaration, only no table appears. It's just a type. And that's great, but OK, how do we get this in and out of Python? CyclePG2 has perfectly good, neat facilities for going both directions, in and out. And the good part about it is once you set it up, it just works. There's a little bit of grungy code you have to write, because that's life. But once you set it up, it works really well. So we take our Squid class and we add this conform method, _conform. And you just sort of copy and paste this, and you say the protocol is this, and then you return self, and then you have get quoted. And what the heck is with that? So there's the CyclePG2 defines the ISQL quote protocol. You implement two functions, _conform and get quoted. It's a little bit indirect. It's one of these, it returns a thing that calls a thing that returns a thing, the thing that Python programmers, including myself, kind of get crazy about this stuff. So conform returns an object that implements get quoted. It doesn't actually conform the object itself. It returns an object which is then called to do the quoted work. The good part is if you implement get quoted in your object, you just return self and you're done. And get quoted returns the object converted into SQL quoted format, which is what? It's usually just a string. If you have internal quotes inside that object, like you're returning strings that could have internal quotes, you need to follow the SQL quoting conventions, not Python's. So that can be a little bit complicated. There are lots of supporting stuff in CyclePG2, however, to handle this for you, so don't panic. You can always just keep calling is quoted on string objects and things like that until you get everything done. To communicate with Postgres, custom types are serialized into strings. We send the string representation to the database. We get the string representation back. Generally, if all else fails in Postgres, you cast things to and from strings. That's sort of the basic, the easiest way of getting stuff in and out of a Postgres database. Aggregate types are enclosed in parens with the fields separated by commas. And then the right quoting conventions on the stuff inside the commas, between the commas. Now squids are easy because we just have 3 numbers. So we just use the string representation since there aren't any fields that could contain quotes in that. So we can make that a much simpler example. If there were strings, you could just call the appropriate get quoted method on these and keep going until you've got everything quoted up the way you want. SQL quoting conventions are horrible, by the way. They are it's really, really unfortunate, but state of the art 1975 level technology. Then we wrap the whole thing in SQL string quotes and add a cast to it. The cast isn't actually required, but it makes for a better example this way. Well, that's great because we wrote the Squid class, but what if you're doing this with classes that you didn't write? What's cool about this is that you can actually register these adapter classes for things that you don't have access to the source code on. Well, it's Python, so you kind of always have access to the source code, but that you don't really have liberty to modify for whatever reason. The adapter function takes that object and returns an object that implements get quoted. So you can write adapter objects that say, here's how I'm going to quote up this object and send it to and from the database. So that's nice if you need to write wrap-up code that you didn't actually write. There's also an as-is method that says basically if stir or Unicode on this is fine, just return in, which is easy for 90% of objects that don't have really fancy internal structure. So, okay, now we create a table like this. We just say, it's a squid. Cool. And then instead of having to break out the fields and all that stuff, we just say, notice also there's a little bit better encapsulation here because we haven't had to explicitly tease the object apart. That's kind of nice. Oops. And then when we insert it, we just insert the Squid object. We don't have to break it apart into fields and enumerate the fields there and do all that stuff. But okay, we got the Squid in. Now how do we get the Squid out? So you need to write a cast function. This goes the other way. It takes the string representation and returns the object. And then we register that function with psycopg2 to say anytime you get a Squid out, here's how you deal with it. The problem, the old joke is you have a problem and you think, I know, I'll use regular expressions, and now you have two problems. You end up writing regexes a lot doing this stuff because you get these strings out and you need to parse them. So, for example, here's a not particularly superly clever regex that parses out the fields of the Squid. So do. Thank God for these. Thank God for named groups. I hate those $1 things. And then you do some casting, and then you return the Squid. I mean, it is a pretty nasty function, and it does. But the good part is it's also encapsulated inside the object. So it's not like every single client of this thing has to write this thing, which is nicer. And then you register it. You say, okay, well, we'll just pass the 7200. I mean, what else would we pass in there? And a Squid and a cast and all that stuff, and we're done. Okay. Sorry. What's 72007? What is with that? So here's a kind of unfortunate thing. PostgreSQL has these things called OIDs, object IDs. Every type in Postgres, in every row, every table, used to be every row, had an object ID. It's a 32-bit number, and it's the unique identifier for that object inside of Postgres. The problem is when you create a new type, it's dynamically assigned. And you need to tell, and when psycopg2 gets the query back, it isn't told Squid quote Squid. It's told here's a 72007. Just deal with it. You know what that is, right? Blank, blank. So we have to tell it. Every database schema object has an OID inside of Postgres. The problem is every time you create it, it's dynamically assigned, so it can be different from every database, and I hate that stuff. Not good. And if you dump and restore the database, it changes. Or potentially could change. So that's not, so this is unfortunate, and it's just one of those things that you deal with. You can, however, extract it from the database. You can do a query, get a null Squid back, and grab the OID out of the result. So the good news is then you can cache that because assuming you're not dynamically recreating the database between queries, which if you're doing that, you may want to revisit that decision. Once you got it, you got it. That's good. And now select just works. You select a Squid, and notice I'm printing the class here so that you know that I'm not cheating. See? So that's cool. Okay, but wait, we had a check constraint on the table. And because we don't want, mutant squids getting into this database, squids with 47 tentacles, no, forget it. We can write a trigger, that's one way of handling it. But, then we don't want to write PLPGSQL because we're Python people and we don't want to deal with a whole separate language. But we don't have to. You can write the trigger in PLPython. The functions run inside of Postgres like any other backend function in PLPGSQL. They run like PGP, they are parallel to PLPGSQL functions. So great, let's do that. One thing to note is that when you create a database, by default, it won't have PLPython installed in it. So you have to create that language. One thing you can do is create it in the template1 database so that any new database you create then will automatically pick it up. The U, by the way, is not because we're it's the Romanian version. It means untrusted. Untrusted languages are ones that the PostgreSQL's typing system is not automatically enforced. So you can step outside of the Postgres typing system because you have direct file system access. So you could set all these permissions on the table and then say, well, that's all very nice, and do fopen, and there you go. All this means in practice is the only kind of user that can create a function in an untrusted language is a super user, because they can do anything anyway. And then you say, okay, I'm going to, great, Christophe, do, and it gives you a nasty error, and it said it didn't like that. One thing to remember is that if you're installing from packages, make sure you apt-get the -contrib modules, not just the base, because you'll need that for Python. And if you're building from source, remember you have to build with the with Python option. That's the 99% of the time. If it won't let you create PL-Python-U, that's why. So, yeah, that's great, but which Python do we get? You get the system interpreter of whichever one you're doing, unless you pointed at a different interpreter when you build it. You can specifically choose PL-Python-2U or PL-Python-3U. Right now, you get Python 2 if you say Python 3. Sometime in the future, this will change. That Python U3 will get PL-Python-U will get Python 3 instead of Python 2. There are no immediate plans to cause that to happen, however. So at the moment, that's pretty safe to get you Python 2. The creation syntax is the same as any other function. Create or replace function with this, and then the string quotes, and bang, there's your Python. There's an automatic module defined called PLPY that has a lot of the utility functions necessary to talk to the database in it. For example, raise notice. And whoop, there it goes. Gives you a nice little notice. Hello world, true. Ta-da. Okay. There is no function body. You don't declare it as a function. It's just the function body. So there's no def at the top. It wraps it. PL-Python wraps this up for you. You can call any installed package. If the interpreter can see it as part of the standard Python path, you can call it. You may not want to call it, but you can. But you can't directly call any other stored procedure. What would be really nice is if you could just type the name of another PL-Python function and run it like any other function, but you can't because of the way Postgres walls off stored procedures. What's called the server programming interface, that PLPY module, you have to write a select that calls it. This blows, unfortunately. So this module PLPY contains all the stuff that lets you call. The other good news, of course, is that you can call any function, including ones that are not written in PL-Python, using that. So, something to note before people go crazy with this is the Postgres backend is single-threaded. Do not create threads. You have a single thread of execution. If you break it, there is no warranty on this. You can screw it. One of the things about being an untrusted language is you're running inside the actual thread of the backend and its memory space. You have every right in the world and every ability in the world to completely screw it up and cause database problems. So don't do that. The chance of actually causing data corruption is extremely small, but the chance of causing really weird behavior from the client's point of view is extremely high if you start doing things like threading. Okay, so here's a trigger. We grab, this is just because we want to throw an exception. We chop our little squid into calamari here by this. The TD is a automatically declared hash or associative array that contains the new data of the row that's coming in, and we say it's a squid, and we split it into pieces there, and then we get the number of tentacles, and we say no if they're more than 32 or less than 3 tentacles. I'm told that actually squids have a fixed number of tentacles, but I'm a programmer, not a marine biologist. And we raise an exception. Otherwise, we return OK. For reasons that escape me, this is the way you say return. This is how you return from a trigger if everything's OK. So OK, in Python. All right. It looks like a pretty normal Python function. A couple of extra stuff there, but so in the TD, composite types like the squid are come in as their string representation. It would be kind of nice if they were already parsed apart for you. They aren't. The thing is, it's a little, to non-trigger stored procedures, they're passed as hashes. They are parsed apart. Why? No idea. But anyway, enough of that. We can attach the trigger here, create the constraint, attach the trigger, So, and then we try to insert a 47 tentacled squid, and bang, won't let you. Great, problem solved. One little thing is, now that we're using composite types, is nulls. So, row types have really strange. A row type is the Postgres term for any composite type, one of these guys. For example, that's true. That's also true. Yeah. Null is great. You know, sum of a zero and a null is zero. Sum of no rows is null. I mean, I don't get it, but whatever. You just have to learn the rules. Okay. Well, now we need to look for squids. So here's a everybody knows explain, analyze, output. So easy to read, right? So this is great. So we're searching for a squid here whose length is between 100 and 101 centimeters inclusive, and it dutifully reads the whole table and takes 2.6-ish seconds to do that. That's not so great. I mean, it is, it's scanning what? 10 million squid, but come on, that's a long time. We want our squid now, thank you very much. So, but squids, fortunately, have total ordering. Squids are ordered by length and nothing else. That's just how squids are, just accept this. Given that, can we speed up searching on these? Yes, we can create full B-tree indexes on custom types with relatively little pain. The first thing we need to do is define a squid comparison function. Well, we just said that the only thing that matters is length, so we just say, do this. It behaves like good old-fashioned comparison functions that have been around since Fortran. Return -1 if left is less than right, 1 if it's greater than right, 0 if they're equal. Okay? And notice here that the squids are kind of doing the right thing. The parameters are doing a much more logical thing. They come in as hashes rather than that weird TD having to parse it apart thing. Sorry about that. I wasn't the implementer here. So we've defined the comparison function, and now we also have to define an equality function. Why? Because. Just work with me here. So we define equality on squids, which is if the lengths are the same, they are equal squids. Notice this is equality, not identity. Very important. They could be two different squids. Squids have individuality. We then tell Postgres about this operator. We do the left we say what the types of left or right are, the procedure to run, what function is the commutation of that function. So equality is its own, so that's easy. What operator is the negation of it? Not equal. And you can read the documentation on these. These are basically hints to the planner about the behavior of these functions. This also says they can be used for hashes and merge joins. Generally, for equality operators, it's just kind of a cut and paste on these guys. You can read the docs about it, which are completely cryptic and undecipherable. Right. So then we define a less than operator. You can kind of see a pattern emerging here. We're not going to go through them all. They pretty much all follow this pattern. Then we define an operator class. This basically marshals together all the operators to tell it everything you need to know about this type. So 1, 2, 3, 4. Postgres has been around for a while, so some of its user interface, some of its APIs are kind of 80s style. So unfortunately, here we go, and we tell it the squid comparison. At this point, we can just do that. We can create an index on it, and it works. It takes a little while because it's calling this Python functions all over and over again, 10 million times. It takes a while, but now we get a much more. We'll get another easy to read explain output. But same query, hot cache. I did a hot cache on both. 12.5 milliseconds. Much better. Same number of squids come back. That's pretty cool. So Short talk. We can implement. You can do this. We didn't have to write any PLPG-SQL to get. We got indexes. We got comparisons. We can use the type fully encapsulated inside of Postgres. We didn't lose any database features here. Standard, Postgres does what it does. And you can have custom operators on these. You can build indexes, do all that stuff. And you say, well, that's great for Squid, but I'm allergic to shellfish. So the thing is, this work, obviously, this generalizes very. For example, there are range types now in Postgres that you can use this with. CI text. CI text is an extension type of case-insensitive comparisons. So all that business about having to create a separate index with lower for usernames, don't do that. Just declare them CI text. Anytime you want an advanced attribute type that you want to adapt to Postgres, you use this same pattern. So for example, if you want to bring CI text into your application, you can do this. Obviously, if you're using a framework like Django, tons and tons of this stuff has already been done for you. But if you have your own custom ones, or you want to do that, or you have a different framework that hasn't gotten there yet, that's great. And you don't have to have defined the type inside of Python. You can adapt the type without having to have written it. So it's just not just for Squid anymore. And that's it. Any questions?
So what about modifying your types? I mean, migrations. I have a feeling that it's going to be really painful, and you should avoid it as much as possible.
Well,
am I right?
Yes. I never hesitate to say something's going to be painful when it is. It's not so bad. The question, you do have to be a little bit judicious in your application. The problem is the synchronization problem. At some point, your code is in a state that knows about the new type, the new version of the type, and the database it reaches that state. The question is, in what order do they do so, and who is more permissive? If the application is sufficiently permissive that it can handle the serialization and deserialization to the old type definition, you're probably okay. For example, one question is, for example, in a composite type, if you're adding a new field, you'll want to decide what you do for a default for that field. Do you set it to null? Do you set it for a default? If your conforming function is sufficiently permissive, you're okay, because you can roll forward the database and then the application catches up at some point. So you can certainly get into really ugly scenarios, no question about that. But generally, with all database schema migrations, you need to think about there will be this window when things are not in sync, and how long is that window, and what do you do during that window. My personal philosophy is that because the database is atomically switched, if you're using a sensible migration system like South or something like that, the database at some point atomically switches to the new version. You want the application to be the permissive one that can handle both versions of the database. That can be a lot of some less than pretty code, especially when you're on database migration number 423. But you can mitigate it.
So the Squid example is very good for didactic purposes because you can understand what you're doing. But so far, I'm not sold on why I would do this route rather than just use SQL alchemy. So can you maybe give more like teasers, like what is possible with this approach as opposed to using an ORM?
Well, that's a really good question. If I would say the first one is if there's a built-in type, if there's a C-level type that's something that's really useful, then obviously knowing this adaptation, but you don't have an adaptation for it, having this adaptation mechanism can be very handy. Like you're using, this is what PostGIS does, for all of its stuff, and it would be kind of silly if you couldn't use PostGIS from Python natively. It's what GeoDjango does for that kind of thing. The composite type example is the other example is if you're dealing with things that do not all focus straight through the ORM. The ORM is not the only access to the database. This is one of, I love ORMs. I do tons of Django writing. I'm kind of the big defender at PGX about using ORMs because I have an application programmer background, and the alternative would make me slip my wrists. But that being said, databases almost inevitably have clients that are not ORM centric, and for doing this kind of encapsulation and maintenance, it can be very handy to be able to build these row types. So, in some ways, I would say this is a skill set that you can kind of generalize to a lot of different things, like other built-in types and things like this. Will this be something you slam into every database all the time? Probably not. But it's but I've done it a bunch of times, and even using an ORM like Django's ORM, it's perfectly fine to you can get both worlds. You can still use the ORM and just wrap up the type inside of Django.
And maybe just to justify what's her name? Sorry, Tom's opinion. Maybe you could also explain that we can use extensions in Postgres. So maybe to perform migrations from a version to another one in an atomic way and transactional way, we could use PostgreSQL extensions.
Well, in the sense of the create extension mechanism?
Yeah, the create extension mechanism.
Sure, the most custom types in Postgres these days, now that we have extensions, that's how they're introduced into the system, is with create extension. Which is, that wasn't quite what I was about here, but if you are creating custom types, that would be the right way to package them up, because then they're much easier to integrate into a migration system, especially at the point you're talking about creating all the operators and operator classes and things like that, because that's a fair number of objects. So having being able to just say create extension rather than dump a whole SQL file in is very handy. Of course, all create extension does in this case is dump a whole SQL file in, but it's a much cleaner way of doing it.
So do you think it's mindful to someone write the support, for example, in an example Django framework, to create those fields, models, and wrap it the Python thing and make it rightly into database?
I'm not quite following, and my apologies.
It's like you're presented here the way to make your own data models in the Postgres, yes? And what about creating the way that Django can make those models right in the database to be consistent with the ORM?
Well, I believe that's pretty much the same comment he had, which is why go through all of these push-ups, as it were, if you can just say, well, I just create my model object in Django. There are two reasons. One is frequently you have things that you do not want to share between models via foreign key. You want to actually embed them in multiple models, for performance reasons, or because you don't want a centralized table, or they're really conceptually autonomous things. But you don't want to have to write them over and over and over, the same field cluster over and over and over again. One example. You could argue this either way. In the particular case, all I can say is that it made sense at the time, was an address. Was one where at some point we were looking at the database and there was the same set of address fields were appearing all over the place. It didn't make sense to unify them into a centralized table for performance reasons, but it was just kind of ugly. And every time we had to change what an address was, it meant changing, touching 12 models. And so we decided to cluster that into an address row type and embed that, and that worked very well. So, this is not something you will probably do, you just replace cluster everything into these row types. But it's very handy if you need it.
So you rather think it's after a post-process thing, like you created your models, create your ORM and touch together and you want to optimize it, then you make changes in the
Yeah,
database.
it's like any software design. At some point you notice, oh man, I've typed this 12 times, and you go back and do it. Sometimes you know in advance, for whatever reason, because the problem domain just kind of drove you towards a particular solution. In the particular case of the address thing I mentioned, that was a case where it was, I'm getting sick of updating this. Well, what really happened was I forgot to update at one point, and it was like, and decided enough. So.
I'm quite scared by the no threading thing, because it's kind of hard to know if you're using threads, if you're using third-party code. So that essentially means just do very little there.
Well, it depends on what you do have to be judicious about what libraries what modules you're calling.
Could you make it a runtime error if somebody created a thread?
Potentially. I'm not familiar with the PL/Python internals. I mean, there are things. For example, if you're calling datetime, if datetime is doing threading, somebody needs to be hit, because that is not, primitive types like that should not be spawning threads to do things.
But you never know if somebody's doing something asynchronous. That may happen in places you don't expect. Probably not daytime.
So you have to be very, very careful.
No, very, very knowledgeable, I think.
Well, it's I'm a little skeptical that routine core Python modules are spawning threads willy-nilly without any documentation that is what they are doing. I'm a little skeptical of that. I'm perfectly willing to be proven wrong because I frequently am. But now, if you're dragging in third-party, if you're doing a bunch of pip installs, and especially if that code has, for example, I would not call requests from inside of one of these. First of all, doing that kind of stuff from inside of a backend, you are gumming up the request loop. So anything, one thing to think about is if you're doing anything that has any kind of asynchronous behavior, a backend stored procedure is not the place to be doing it, because the client's waiting for you. It's that kind of thing. So it does mean that you need to. Postgres isn't an application server. It's not intended for. The backend loop is not intended for that. But you are. The upside is you get to live inside the database and you get high speed access directly to it. The bad news is you do have to be very judicious about what you do.
I might have missed it, but did you give any numbers about what can I gain from it in terms of speed?
No, I didn't.
Wouldn't you?
Well, had I the numbers close to hand, I would. But you are saving the. A part of it is it depends on how far away from the database server you are. If you're talking to the database server over a local socket, you're probably saving some, but not a ton. If you're talking through, if you have two VMs in Amazon, one's way over here, and you have PG Bouncer and PG Pool and a bunch of stuff between them, you're saving a lot because of the request overhead. So. And some things like building it, like index operators, you have to do inside of the index operators and triggers. You have no choice, so the overhead's not an issue there.
Yeah, related question to the performance overhead. I guess most of these, at least for these examples, the performance overhead is basically on insert, right?
Well, it's on the main performance overhead is there are two sets of performance overhead. One is comparing doing everything through database operations remotely, from the client, as opposed to running it inside the Postgres core, inside the backend. The other is Python overhead versus the raw SQL execution overhead. This is a little bit outside of what we were talking about here, but I'll give sort of a general rule. People frequently ask, well, should I use PL/Python because I like Python, I'm familiar with it and all this stuff, or should I use PL/PGSQL? And the answer is, how much of this is pure querying? If the answer is a lot of it's pure querying, you're probably going to be it's probably going to be faster running PL/PGSQL, because it does kind of have privileged access to the database. Its connection to the database is faster than this, in part because it's pre-parsed and things like that. If what you're doing is mainly computation, though, with a little bit of database access, the Python will be faster. Almost any language will be faster because every expression in PLPG-SQL is actually executed by the query engine. So if you say select 1 plus 2 into something, or I equals I plus 1, what you have done is built a query that queries I plus 1 from the database and returns the value and assigns it to I. That's not going to be as fast as running it inside the Python interpreter. So there is a little more overhead because it takes a string and it's basically doing an execute on it. It's having to parse it up and do all that kind of stuff. There is a way of saving plans. So if you're doing a bunch of, like a ton of inserts or something like that, you can save the plan in Python and do it repeatedly.
Any more questions? Yeah. Okay. Thank you very much, Christophe.